And now we're recording, so that's good. So now it looks like Selena just tuned in. Hey, Selena, good to see you.
Hello.
Hello. So I was just asking if there were any questions about homework number 10, I think it was. This is where I'm at right now. I'm scrolling through the screen. This is homework 10. It looks like people tried it and they got through it. There were some videos for you to watch. I hope you were able to get through and see some of those. Let's take a look at the next homework assignment. So if we're into course content and we see homeworks, I think your next homework assignment should be homework number 11. Now, let me just make sure I got the assignment open for you guys and assigned. So I think, yeah, it looks like it's due on the 19th, which will be Wednesday of next week. So that's end of day Wednesday. Let's just make sure the due date is set properly, and it is. So you've got your assignment there, and that is homework number 11. And that's on HTML, hamming, and keyboard input. So HTML, of course, you know that's the hypertext transfer markup language, which is pumped out by web servers everywhere in order for browsers to give you dynamic content. HTML is a markup language that was devised in 1994 with a specification called HTML 1.0. Tim Berners-Lee came up with this as a mechanism for showing formatted text on the internet. So when we had before the web was we had the internet, and the internet evolved into a mechanism where people were using many specialized applications for transferring data, such as file transfer protocol, for getting access to remote logins, such as Secure Shell and Telnet, for doing email, such as Simple Mail Transfer Protocol or SMTP, and for doing other sorts of general purpose internet work. And networking included such things as TCP/IP and sockets and the whole 9 yards. And in fact, since 1983, they standardized on internet protocol. But the HTML represents what I will call the graphics user interface, which was placed on top of the internet. That is what we now have come to know as the web. And so when we think about network programming, and this is one of those sort of interesting terms of the field, in the context of HTML, often what we're doing is we're doing a kind of screen scraping, which means we're taking the HTML in and we're converting it into another format. It's just data processing. But by saying just data processing, we kind of hide the complexity of dealing with what is essentially a very poorly formatted markup language. And the reason I say that is because it is entirely possible for you to have tags that are unmatched in HTML. And I'll show you what I mean by that. It's a very interesting turn of events. Let's bring up a Unix system like this one. This is a Raspberry Pi. Now, it has a text-based browser called Lynx. And if you, oh, maybe it doesn't have a text-based browser called Lynx. Let me see if it's on my Mac. I thought it did. It's not working. Doesn't matter. We'll try a different browser. We'll go to attachments, Emacs, HTML. Oh, I know. foo.html. I'll write my own little HTML web page here. And this is something you may have done yourself. It's basically HTML is matched with a tag. Those are matching tags. Now, here's a header. I'll say H1, and this is heading 1, and we'll end it H1. Now, here is a non-matching tag. Paragraph, para, paragraph, para 2, para 1, called para 1, para 2, para 1, oops, para 1, and we'll do the other one, will be para 2, there. And then we'll do another non-matching, we'll call it break. This is a break. And we're not going to match these things. These are non-matching. If this were matching, I would have end para like that. But because it's non-matching, I think we can expect the browser to recognize it and do the right thing. And what we'll do is we'll put all of this into the body and the HTML. And then I think we'll save it and we'll use a browser. This is called CMonkey. And I think CMonkey can do a file open. And we'll see if we can render this file. It's in Lion attachments. And there it is. So even though I didn't end the para over here, it still recognized it as a para. Even though I didn't end the break, it still recognized it as a break. So if you had well-formatted HTML, you might call it HTML X or XHTML, in which case you would have a begin and an end for every paragraph. In other words, if you actually did this right, this is what you would expect. Oh, and look, the body was not terminated properly either. Wow. So let's see if we can reload. There, didn't terminate the body properly. So you can kind of see the browser doesn't really complain about the fact that things aren't correct. It just takes it. It just takes it. Similarly, if you found that there was, here's a good one. Let's look at Apple. Apple has a symbol AAPL, stock. Right? So now, if you look at the Apple stock in Yahoo Finance, you can see that there are these key parameters of performance. And these include things like how much debt Apple has. Let me see if I can get the statistics up. It's funny, you click on the statistics and nothing happens on this computer. Here we go. So now if you scroll down to the bottom, you should be able to see something like cash flow, 109 billion. Total cash, 51 billion, total debt, $111 billion. Now you can mine for all of that stuff and it's being presented to you in HTML. And the process of data mining these things is a legitimate reverse engineering of the HTML. Let me see if I can get out of this. It's very slow. He's not letting me get out. It's very interesting. Let's see if I can Yeah, there's something screwy here. I wonder if I have to stop the recording. We'll force quit out of this. And then what we'll do is we'll quit out of this. And then I think maybe I'll quit out of this. I got too many things running. And then I think maybe I'll quit out of this. Let's make sure there isn't any more stuff running here. I'm going to quit out of this. Oh, I don't want to quit out of Firefox. So now what we'll do is we'll take this. I wish I could get this floating panel and hide it. I don't think there's a good way to do that. Hide floating meeting controls. Ah, thank God. So now let's take a look at Apple. So now we run a little program that can do the data mining by screen scraping. And here we see the $109 billion worth of cash flow. We could see the $51 billion worth of cash, the $111 billion worth of debt. This 1.0813 represents a growth rate, which you got under the analysis tab. This is a PE ratio, if memory serves. It's a very interesting thing. You can go out and you can get all of this data. And that's kind of neat. And if you take that data, you can use it to create other data. So for example, here we'll go in and we'll use what they call Microsoft 365 Excel. Now, Microsoft 365 Excel on the web is really different than the one that's on your desktop. I don't know if you're familiar with it, but it has the ability to dynamically get financial data, which is kind of neat, because what that means to us is that we can use the data that we've data mined, and then we can create derivative data. Question of why it's so slow remains open. So here what we have is Apple, AAPL. We'll put it in there. And we'll paste in the associated data. Now over here, to identify this as a stock, we'll go in and we'll identify it as stocks. You don't get this with the desktop. And so now you can see he's mapped this symbol into a NASDAQ-based exchange. He's giving you the symbol, and now we can do derivative computations such as cash flow, owner's equity, market cap. This is the market cap. And you can see the formula involves market cap. It's the simplest thing. Here we have cash flow estimates or for the future based on the growth rate. And this growth rate was 1.08%, so 0.08%. And so then we do the computation to determine if it's of good value based on the model, based on a cash flow model. And so I'm not sure if you're familiar, but accounting is different from finance. Accounting is about the past and the present. Finance is about the future. So when you estimate the value of a stock, you're looking toward the future cash flows with a growth rate in order to be able to determine the present value of the stock. That means that you have to compute the cash flows between now and eternity and then discount them back to present day in order to be able to determine a present stock's valuation. That's a typical approach to doing these types of computations. And so I've done that with several different financial organizations or groups, I guess you would call them industries, different industries, the lumber industry, miners, defense, housing, oil, food, China, and just general stocks. And Apple falls into the general stocks category. So that's sort of the basic idea of the data mining. So when you go into HTML, it's much more than just sort of like being a web designer. If you're trying to write programs that can actually read HTML and process them, what you're really doing is a kind of data mining. And data mining is a really fascinating area where you can do network programming and add considerable value. So generating the HTML dynamically with a computer program is one aspect, which what I would call synthesis. But the other one, where you take the HTML and you create derivative data from it, I will call analysis. This is not the same thing as the HTML course you may have taken where people are designing a web page. You know, that's different. So the HTML editor kit enables you to render HTML so that you can render it on a swing panel. There's also a mechanism in here where you can read the paper and learn about how you do stock statistics mining. So I created a parser using Yahoo Finance, and then I was using that for my analysis. Then I have another video here, which you can look at, called which does synthesis using something called FreeMarker. And then with FreeMarker, you're able to actually create HTML on the fly dynamically from all the dynamic data that we've been generating. And you can preview that not just in a browser, but in Swing using what's known as a JEditor pane. So there's a video on that as well. So that's kind of what this homework is really about. It's about analysis and synthesis of HTML. Then there's a separate topic. This is like changing gears, and it's called forward error correction. So in the case of coding for error control, there are two kinds of error control. One is called backward error correction, and the other is called forward error correction. Now, in backward error correction, you'll do something like automatically request a retransmission because an error was detected. So error detecting codes fall under the rubric of backward error correction. With forward error correction, you cannot go back to the transmitter and ask for a retransmission because you're reading the data from something like a media file, like a CD player or a DVD, or you're receiving it as the Voyager satellite from a deep space network, and you can't just go back and say, please send it again. Or you're transmitting it from Voyager to the deep space network. You're beyond the heliosphere. You're an output-only device. You're not listening. So essentially, two-way communication is not possible. So with just one-way communication, let's say off a magnetic tape or some sort of computer media, which might have some flaws in it, you put in what's known as an error correcting code. And so what you'll do is you'll take a look at the paper called on Hamming codes, and this was in the 1950s Bell System Technical Journal. And then you'll take a look at the video on Hamming codes and the introduction that I give you to Hamming codes. These are the most basic of codes. And so there's 39 questions in total. MIME, multi-purpose internet mail encapsulation, is a standard which was created as a part of what's known as a request for comments. So when you look at the RFC for MIME from, I think it was the 80s, you'll see that people are using these requests for comments to try and propose standards. And so here's the 1982 RFC for the ARPANET. That's the Advanced Research Project Agency Network. what they wanted to do was they wanted to encode text in encode binary in a textual format. They called it UU encoding, or Unix to Unix encoding. So this is a base 64 coding system, which takes 64 different characters from the American Standard Code of Information Interchange and assigns each one to a binary number. And then transmits that through a mail transfer agent, which can handle only text. For the mail transfer agent's receiver, to understand what the text represents, you use a MIME textual mechanism for describing that text. And so if you used something like, here's a good example, text /RTF, that would be a rich text format file from Word, or text /HTML. Well, that would be an HTML file that has been UU encoded, or something like image/GIF. Well, that might be a GIF image that's coming in. You could have image slash, you probably, I'll put this in quotes, image/JPEG. So this is what you call process data. And if you wanted to decode all possible process data, you're probably building something that's too complicated. So what they do is they give you plugins for each one of the new process data. So if you decided that you needed a new image in the Selena format, well, the browser might not know how to decode an image in the Selena format, and therefore you need a plugin that will decode it, or you need a decode mechanism on demand, which you might do with an applet from some Java program. So these are the kinds of things that you have to deal with when you're dealing with process data. It's in a layer. It's part of the substrate, which you would call the presentation layer. So this is presentation layer stuff. HTML is in presentation layer. The browser is in the application layer. So when you look at here, we'll see if we can find TEXT/. So this is the quoted pairs they established for MIME data types. And in fact, you can find a list of MIME data types. And probably, yeah, so here's text/HTML. Here's a bunch of other ones. Oh yeah, CSV is a typical one. Your browser knows how to deal with CSV because it has a decoder for it. And it knows what to do. Same thing with text/PDF. Knows where the PDF encoder is. So there's that. Let's see what else we got. So you've got to read in the book Java for Programmers. You should be on page 332. And let me see if I got a copy of the book handy here. I'm not, oh, here it is. Yeah, I'm turning to page 332 right now. So that's chapter 20. And 21, viewing HTML in Swing. So that's all chapter 21 stuff. So let's see if we can't, geez, it gets so slow when it's in record mode. I should probably only be recording from the iPad. But it doesn't matter, it's too late now. I'm not gonna switch it. So you'll be reading chapter 21, building an HTML synthesizer, building an HTML viewer. And this is going to lead you into chapter 22, which is on using the keyboard. So learning to use the keyboard and the mouse in Java, these are essential sorts of things. And so one of the things you'll notice is I've got my own mechanism for dealing with mnemonics. And these are some of the what do we call these, meta characters that you will use in front of a keyboard. So you can modify keys. They're keyboard modifiers, they call them. So shift, meta, del is for delete, control, alt. So if you can intercept the modifiers alt, control, and delete, you can process those in Java. Let's see what else we got in here. I think the rest of this is going to become relatively straightforward once you have a chance to view the videos. Let's see. This is all bit manipulations. So in block coding, what you're doing is what's known as modulo arithmetic in binary. So with block coding, you're basically doing division with ones and zeros, and or multiplications with matrices that consist of ones and zeros. And so those are considered what you'd call a block. And so those blocks of bits, when they're multiplied, tell you where the errors are because of the redundancy built into the code. And so this is one of those things where it really pays to kind of watch the video and the lecture on block coding. So I think you guys should be able to do that. And that's what I have for you for today. The way I'm doing this inverting of the classroom, is this working for you guys okay?
Yep.
You're all right with it? All right, that's good. So when you go in to this paper here, I think, yeah, he brings in the PDF file, so he knows how to decode it. And then I think you should be able to just open this right up. Yep, there it is. So now you can see how you can do data mining within Java. And in this case, I have what we call, I don't know what to call it, a third generation address book. The address book is right over here. This is my address book. And what I did was I have data mining built into the address book. And at one point I was going through and doing a lot of the financial data mining, but also other kinds of data mining, like mining yellow pages in order to get things like databases and put it into the address book, which is really just a flat file database, and then proceed to do things like here, get a list of all the lawyers, and then put it into the database of the address book. And then you could print mailing labels for all the lawyers. So for example, when you go in over here and you want to see, I don't know what to see. Here's a fireplace guy. Oh, it came up in a different screen. So here it is. So now I can go in over here and I can go print Dymo labels. And now my Dymo label printer is printing the thing directly. So if you want to, you can print labels for all of your lawyers and then go and do a mass mailing or something like this and tell them you're available as an expert in something or other, software, I suppose. And so this is a kind of a different approach to building address books than you might have seen before. It has a chat facility, screen recorders, you can just keep adding things to it. And so here's an interesting thing. You can take the address record and convert it to XML and put it into the clipboard, for example. So then if you go into yeah. So now you have, this is well formatted. It's an instance of the address book, JAddress book address record. So that is a fully qualified class name. It has all of the properties that have been changed inside of that class so that the instance can be recreated. So an instance of the address record can be decoded by the XML decoder, and then you can bring that record back in. So this is a serialized object that has been serialized to XML. And XML is a extensible markup language that in this case is specific to Java. So now you can take instances of objects, transmit them over the network or save them onto a file or do whatever you like, and you can get those instances back. So instead of creating some sort of a custom format for your files, this will enable you to use the built-in object output stream and encode it into an XML encoded stream. Save it to a file output stream and read it back in later. So this is a what I would call a mechanism of serialization, if that makes any sense. And you can see why it's well formatted. The begin tag always has a corresponding end tag. So here's the string tag, which has an end string tag. And he tells you, well, this is the address property in the address field. And so when you go back over in here, you can see here's the address field, and here it indeed says, and it has this stuff. And there's probably something in the name field. Here's the name field, and it's got the fireplace. And so there's the fireplace way up there. And so there's this other field, which is the info field, which is over here. And then it tells you exactly when it was created using the less than and greater than, because those are actually in there. So the meta symbols were spelt out. So this is a direct correspondence to the data which is stored in that record. Kind of neat, right? So that's well formatted. What happens if you change this object so that these properties don't exist anymore? Well, then what happens is you break serialization. It will not be able to read it back in. It won't know what to do. And it'll give you an error at runtime. So you have to be careful if you're depending upon serialization to keep the class preserved. Don't change the class that you've been using for serialization, or all the data that you've written out in the past will break. Just kind of an unfortunate circumstance. So there you have it. We have a final. It's going to be due on the 17th of May. We'll have a, I think, one more week to go. How many weeks are there left in this semester? This is the 13th. So you're going to have, I think, the 20th. Is that right? I think that's okay. And then we'll have another class. I guess it'll be on the 27th. And that will be our last class. So as far as I'm concerned, there are still 2 weeks to go. The semester officially ends with the last class on May 1st, which is a Monday, but we don't normally have class on Monday. So our last class will be the last Thursday of April. And we're going to have our final, and it's going to be online. And I will make that available to you if it isn't already. I think it might be already available. Let me just check. So you'll have 2 weeks to do the final. It's all done on Blackboard. This one here, JDBC and servlets, I think is due Wednesday. No. Yeah, Wednesday the 26th. That's it. That's your last homework. Yay, last homework. And so you guys will got 2 more homeworks to go, and then you're done with the homeworks and done with the course. Yay. Now, as far as the final is concerned, I think I gotta reformat this a little bit and release it to you. So I will try and do that as soon as I can. But I think you've got your hands full now. You've got 2 more homeworks. One due next week and the other due the week after. Do you have any questions for me?
No.
No, I don't have any questions.
All right then. Well, I thank you all for your attentions, and I hope you have a nice evening.
You as well. Thank you.
Thank you. Bye-bye.
Bye.
Good weekend.
Thanks, Professor.